Oh, hi there. I'm Michael Fudge, just busy here in my workshop. I'm hoping that you'll be able to hammer home this lesson and nail it. At least that would be the idea. Okay. Hello again, everyone, and welcome back. Now we're in Unit 5, which is the SQL Select Statement Part 2. Let's talk about the agenda. So what we'll discuss in this unit is mapping versus reducing operations and how this applies to the select statement. This will help get a very solid understanding of how various aspects of the select statement actually work. And it will also give us some backstory / knowledge for when we start to get into looking at distributed databases as well. We'll look at aggregate operations, that is, operations that take rows of data and then reduce them down to a summarization of rows. And then in that, we'll look at the group by and having operators, or group by and having clauses, and the aggregate functions that go along with that. Then we'll look at some complicated queries that involve using the select statement more than once and understanding how we can simplify those statements using the with clause. And we'll also take a peek into window functions, and specifically the three kinds of Windows functions that are out there: the aggregate functions, the value functions, and the ranking functions. And we'll spend a lot of time helping you understand how window functions are different than aggregations, and how they help you avoid writing very complicated select statements with subselects in there. And there's actually some things you just cannot do in SQL without Windows functions, so they offer tremendous value to us. And then we'll conclude by talking about a piece of data definition language and a new database object called a view. And basically what a view allows us to do is take a select statement and save it under a name in the database so that we can query the view as if it were a table. All right, so let's get started with the unit then. First, let's talk about maps and reduces. And so a mapping function is any operation that applies in SQL, what we're talking about, or in tabular data. A mapping function applies to a row, a tuple, in the query, and then what it produces back is a tuple or not. So the mapping function may be something as simple as take this tuple, and if it has a certain value in it, display the tuple again, otherwise do not display it. That's how a where clause works. Another kind of mapping function might be take this tuple and only display these two columns or these two attributes from the tuple. That's how a projection works. Both of those are examples of mapping operations or mapping functions. So we can contrast that to a reducing function. A reducing function applies to a set of rows in the query. That is, it applies to multiple rows in the source, but it yields a single tuple as output. So as input, you might have several tuples that match a certain set of criteria. That is, you might say, let's grab all the rows where the department is customer service and employees. And then as an output, you might give a count. You might say there's 7 employees in customer service. That's called a reducing function. So it's important to understand whether you're doing a mapping operation or a reducing operation. To this point, we have done nothing but mapping operations. So this is our opportunity in SQL Part 2 to introduce the reducing operations. So let's go through an example of a map. So I have select name and GPA from students where year is junior. Of course, step 1 is we start with from. So there's my from clause. Then step 2 in the select processing is to perform this where clause, which actually is a map. It is a map over each row where this condition is true. So we ask ourselves for every single one of these rows, is the year a junior? And when we're done, we end up selecting only the juniors, and then we produce a table, which is really an in-memory table, a row output of just values that match this operation. Okay, so again, it's a map because the rows, the tuples are still there. The original tuple is still there somewhere. See, we can line them all up. Then this part, the projection, is another map. And this map says, with this input, map these so that only I take, if I have this whole tuple, I just want to take the name and the GPA from that tuple and produce another set of output. Again, we have not removed any of the original rows or reduced any of the original rows, if you will. This row here, airing your tires, can be traced all the way back to the original table. So those are mapping operations. Again, 1 in, 0 or 1 out with a mapping operation. That's basically how it works. So let's contrast that to a reducing operation. So this query is new to you, and it has a reducing operation right here in it, count star, which says count the rows. And we're going to again start with the from, and this is the entire table. And again, we will apply that where clause, which does a map, so that we have this output of the 3 juniors. Now, here's where the reduce comes into play. The reduce takes these 3 juniors and applies this aggregate function to them, which says count them. And then what we get back is it collapses down into one row, 3, with the value, juniors with the value 3. Sorry about that. So that is basically how a reduce works. A reduce, you can see there's no way to trace the output of the reduce back to the original rows. We have lost them, right? So now you have applied a function that is in essence, or an operation that is in essence one way. Whereas before, in the previous example, we could find a way to lineagely trace that back to the original row in the table if we had to. We can no longer do that here. We have lost the row. Okay, so as you remember, this was the select statement. So we had select, and then you could say top or distinct. These are optional. And then you have your columns, then you have from table, where, order by. So let's add in the clauses that deal with reducing. So we have group by and having. Basically, group by is the operation that does the reduction, and it will take whatever column that you have here in columns, and it will combine those columns together and then apply whatever reducing function you have, like count or average or sum or min or max, by those columns. Now, the columns that you group by do not necessarily have to appear in the projection, but any columns in the projection must appear in group by, and we'll see that in a little bit. Now, after you do the aggregation, you may want to then in turn filter the output of the aggregation. So that is, apply something like where, but to the output after group by, and that's what having does. Having is a clause that you can only use after you group by, and what it will do is it will filter the output of the group by according to this condition. And then it continues on with order by. So let's revisit our statement processing. We write it like this, as we just showed you. You write select top, then your projection, from, where, group by, having, order by. But this is how it gets processed. It gets processed from where, then we apply the group by aggregation, then we apply having if it's there, and then we do the column projection. So the column projection comes after we aggregate those rows down with group by and then filter them with having. So you might have our big table again. I'm going to do my arm exercises. Your big table, your where clause makes it a little smaller. Your group by then collapses it even more, and then having might actually collapse it even more. And then we apply the column projection, and then we sort the data and then apply top or distinct should we need to do that. All right, before we get into a demo, let's learn a little bit about aggregates and how this reducing works. So here are the aggregate functions that are available to us. They all have different purposes, but they all sort of end up yielding the same thing, which is less rows in the output than when we started, because they are a form of summarization. So count star is used to count actual rows or tuples. So it doesn't look at an individual column, it looks at the entire row in the count. And then count column will count the non-null values within that column. So in many cases, count star and count column end up yielding the same results or similar results. The only difference is if there's nulls in the column, you won't get the same results. So count distinct column is like count column, but it will only count the unique values from the column. And then min returns the smallest value in the column, and max returns the highest or largest value in the column. And min and max can be applied to any data type. So you can say, what is the min of someone's name? And it would pick the name that begins with an A, because that's the first value. And then if you said, what is the max hire date? It's going to pick the hire date that's closest to, that's furthest in the future. So the largest date is the one that's, closest to today or in the future, right? The smallest date is the earliest date. Now, average and sum can only be applied to numerics, whether they're, precise numerics or approximate numerics does not matter. Average does an average, and sum obviously adds them up. So those are the aggregate functions. So let's start with a little bit of a demo here. And in our demo, we're just going to show you how to use some of these aggregate functions, and we're not going to do any kind of grouping yet. We're just going to show you how the aggregates work, so you can get a good idea of that. Okay. All right, here I am out in Azure Data Studio, and I have executed this select over the employees table, and we see all of the data. So you might want to know how many employees are in this table. Now, one thing you could do is you could just scroll down and then look at the bottom and say, oh, there's 67 rows in here, right? That's what I see right here. But in most cases, like if we look at paychecks, there's a lot of paychecks in here. And, I'm not going to scroll and find all the paychecks. That's just going to take forever. So this is where you can use an aggregate to help you. And in this case, I will count the rows with count star. And let's find out how many paychecks are in here. There's 7,465 paychecks. So I'm going to call this as paycheck count, and give an alias to the column. Very good. So you see how this is a reducing operation. I started with 7,465 rows, and then I ended up with one row that just has the count in there, applying this operator. So maybe you want to get a count of, if I go back to paychecks, let's do this again here. Or maybe I guess we could use employees, but I'll stick with paychecks because I'm here now. There is a hourly and salary. You might wonder, is there something else in here other than hourly and salary, right? So what I can do is I can count. If I count paycheck employee payroll type, from paychecks, what I'm going to get is 4,765, because there are no values of null in here, and you would expect that. You wouldn't want to issue a paycheck to somebody and not know if they're an hourly or a salary employee. That would be a problem, right? So, knowing that, what we want to do here is count distinct, and that's going to count the different values in that column, and this should just be 2, right? Because there's only 2 different values. There's, hourly and salaried. Likewise, you might want to know who the earliest paid, what is the earliest paycheck in here, right? So in here, there's a pay period. And if I get the smallest pay period ID, then I'm going to know the earliest that someone got paid, right? So I can do select min paycheck pay period ID. And that's going to give me the earliest that someone got paid. 2018 January 12th as earliest paycheck. And I can also do a latest paycheck too. I can add that right here. I could say max, the same column, as latest paycheck. I can do that. Let's just run that. Cool. So the earliest paycheck was 2018 January 12th. The latest was 2020 4/10. I can also, if I want to keep doing the same query, I can say, give me the smallest amount of the paycheck. So I already forgot my columns in paychecks because I'm an old man. So I'm just going to go down here and cheat and use payroll paychecks. And there's probably a column in here that tells me gross pay. There it is. So let's get the minimum gross pay. As smallest paycheck, and then maximum gross pay as largest paycheck. Now you're not going to know who that person is because we lost that right to see that by aggregating these rows. That is not the kind of answer that you can expect to get out of this sort of query when you use an aggregate operator like this. That's not what you would expect to see. So the smallest paycheck is 0. They didn't work. And then the largest paycheck is $2,724 and looks like 55 cents as far as paychecks go. So you don't know who this person is. But again, you won't get that information because of the way we did it. You would have to use a window function to do that. And we'll talk about window functions later. Let's continue on. Maybe you want to find out what the total amount we paid out is, right? So let's take a year. Let's just take year 2020, right? And let's see how much we paid out in total in that year. So let's say select max or sum paycheck gross pay as total pay. Let's do 2018. And let's, for grins, let's also sum up the hours. Paycheck total hours as total hours 2018. And then we'll put a where clause in here, where total, where paycheck pay period ID is bigger than or is, let's just use between, is between 2018 January 1st and 2018 December 31st. There we go. And let's see what we get here. And I got some errors in here because I can't do something right here. Paycheck, pay period. Oh, I forgot from. From paychecks. It's funny how you forget from and you get these weird errors with invalid column. You know, but it's easy to do that when you're talking and typing. Okay, so it's not called paycheck total hours. It's probably called total hours worked. Yep, total hours worked. It's good to show errors. Shows you I'm human, right? There. So total pay in 2018 is that, which is a really big number. looks like 1.4 mil and 62,885 hours in there. So this is basically how the aggregate operators work. Now, it would be great to be able to show like year and then this and then the next year and then this and then the next year and this, and that would be completely awesome. And we will learn how to do something like that in a bit when we talk about using the group by clause with the select statement. So let's get back to it. All right, let's talk about the group by clause. The group by clause is added to the select statement. And what the group by clause will do is it will take the column that you put in the group by clause, and if it is put in the select clause, you will see the unique values that you've grouped by, and then this aggregate operator will be applied to each unique value. So in essence, it takes the source data and then groups it according to distinct values, or unique values, if you will, of employee department, and then in turn it applies this operator to that. And this is what makes aggregations so powerful, is that you just don't have to do them over the entire set of data, but you can in essence sort of partition the data using group by, and that partition will control how that aggregate is applied. So the important thing to recognize here is that if you include it in the select projection, it must be in the group by. But the reverse is not true. I can group by this and then just not show it, which would be weird, because then I would see these counts 5, 15, 11, 10, and I would have no idea that 10 was hardware because I'm not showing that in the projection. So while I certainly can omit it, it doesn't make sense to do the omission, actually. So the converse of that is not true. That is, you cannot include a column in the group by, like employee ID, and then, you cannot include a column in the projection, employee ID, but then not include that column in the group by. It has to be in the group by. But the converse of that is not true. If I can have employee ID here and then leave it out up here, again, that wouldn't make a lot of sense. But if I want to show it, I need to group by it. And when you have this, where you put something in the select line and it's not an aggregate, like this, and you don't group by, you'll see column invalid with the group by clause. Basically, what it'll say is you need to add it to group by. It will tell you that. See, invalid right there. So let's talk about having then. So having is a clause that filters the rows of data after the group operation occurs. So we have a reduction that has occurred. We're no longer looking at original rows. We're looking at a summary of rows. And now I want to apply something similar to the where clause, but to this. So in essence, what I need to do is I need to include a having clause. And the having clause applies a filter to the output of the group by. So one thing to note here is I cannot say having row count, because again, having comes before the projection. Remember, the projection occurs almost last. So the SQL parser does not know what row count means yet. So you have to actually use this weird syntax where you say having count star bigger than equal to 10, which is saying, having the row count bigger than or equal to 10. And so because I only asked for this condition, I lost, hardware, housewares, sporting goods, and toys from the output. I could not do this with the where clause, because at that time I didn't know how many there were in each department. So that sort of gives you the gist of how and why to use having. When it comes down to whether or not you put it in having or group by, having or where, always try to put it in where, and only use having when you need to use having. So if you can filter with where or having, use where, because where will reduce the number of rows that are applied to the group by operation, which will in turn speed up your query. You should only have having when you're applying it to some kind of output of the aggregate like this. So for instance, if I wanted to filter this and just remove hardware, I wouldn't use having for that. I would use that in where. I'd say where employee job title is sales associate and employee department is not hardware. I would not try to do that in having. Having is only for, this column here because I can't figure out this column. I don't know about this column until after group by. Okay, let's do another example in SQL. We'll analyze some paychecks from Q1, January through March of 2020, and we'll look at some various aspects of this data, and I'll show you that in SQL. So let's get to it. Okay, I'm out here at in Azure Data Studio again, and I already wrote a query to get us started here. These are the paychecks that are in the first quarter of 2020. That is January 1st through March 31st, and it's just the paychecks. And let's do something where we look at the hours worked and the payroll by hourly and salaried employees. So let's do this. Let's get a count of the rows as paycheck count. Let's get a sum of the paycheck total hours worked as total hours worked. And let's get a sum of the paycheck gross pay as total gross pay. Now, I'm just going to run this. This is no different than what we learned before. So there's 857 paychecks in this pay period, and that's the total hours worked, and that's the total gross pay. Now let's start to use group by here. I want to add to this. The payroll type. Now, when I add it here, I'm going to get an error that says, dude, it's not invalid in the select list because it's not contained in the group by clause. Okay, so this is the common error that you get that tells you need to add group by, and then you need to put this column in the group by clause. Now you'll get output, and it divides those aggregate functions among the different payroll types. So now I know that 727 paychecks were hourly and 130 were salaried, and then these are the breakdowns of hours, and these are the breakdowns of gross pay. Pretty cool. So I might want to normalize this and get, like, for example, gross pay divided by the number of paychecks, or gross pay divided by total hours worked, and I can easily do that. Just adding more column projections here if I wanted to do that. I can also do this by department, right? But department is over in the employees table, so I have to do a join, right? I have to say from paychecks join. Actually, let me save this query because this is a nice one. And I'll just put it below here. And let me write enough. Let me just, before I start editing this one, right? So let's join that to employees on paycheck employee ID is employee ID. Again, I'm joining on primary and foreign key. And now that I do that, this query shouldn't change at all. Okay, but now I have access to the columns from the employees table. And in here, you will see that I can grab department, right? So let me do this. Let me add employee. Let me take this out and add employee department. And then let me group by employee department. So there you go. I have different departments, how many paychecks issued to each department, the total hours worked by each department, and the total gross pay by department. Now I can order this by, I can put an order by, employee department if I want. I can add that. Now default, the way the grouping works is it's going to group, it's going to order by the way that it grouped, because it needs to arrange those before it can group. But I can also order by, for example, maybe I want to put the total gross pay first. Now, because order by executes after the column projection, I don't have to do this. I don't have to say order by sum gross pay. I don't have to do that. I can. See, now the highest gross pays are at the lowest are at the bottom, the highest are at the top. But what I could do is, if I want, I could just say total gross pay here. Because that alias is now available to the order by clause. And there you have it. So minimum, maximum. So it might be kind of useful to do this. And then you might want to, let's talk about using having, okay? So let's add another count in here, which is a count of employees by department, right? So I want to do a count distinct employee department. As employees in department. Let's try that. See if that does what I want. Okay, that did not do what I want. Maybe I just want to count employee department. That's probably not going to do what I want either. That's going to give me the paycheck count. Right? That gives me the paycheck count. So I can't sort of do what I want. I might have to use a window function to get exactly what I want here, because the way I'm grouping by department. I can't get a count of employees when I group by department, because I'm really joining these two tables together, right? So the order of operations here is throwing me off. And again, this is another reason for window functions, because as we'll learn, I could write this as a window function. So let's do this. Let's add in let's go back and add in hourly and salary. Let's break this up by department, and let's break it up by payroll type. So paycheck, employee payroll type. Let's add that back. And because I am displaying it, I need to group by it here. And now I should get a breakdown by, whoops. I screwed something up here. Oh, I put that in the order by, Mike. There we go. Now it's in the group by. Good. There. So now I have breakdown by department and also by hourly or salary. Now I probably want to change the sort order so that it sorts by department and then payroll type, because that's probably going to make more sense for this report. Okay, that looks better. So now I have clothing hourly, clothing salary. And then customer service hourly, customer service salary. Okay. Pretty cool. So I might want to do this, and then let's say I only want to show this where the gross pay is over, the total gross pay is over 20,000, right? I'm just going to throw an arbitrary number out there. To do that, I need having, because I need to filter what I see here, right? And this column here is only available after group by. I can filter by this, like if I just want to see salaried, I can put that in the where, right? Because this comes out of the join. But these are aggregations. And so if I want to use an aggregation, I need to ensure that these values are available to me, and they are only available after group by. So I'm going to put having. And I can't say having total gross pay here. I can't do that because, again, these columns are not available until after halving, right? The aliases here are not available. So I need to use the aggregate. It looks weird and it looks inefficient, but trust me, it's being as efficient as it can. So having the sum of the gross pay be more than $20,000. So let's run that. Okay, and now I see it's still running my query below here because I didn't highlight it. But now you see only values here, only rows where the total gross pay is more than 20,000. Okay, so let's quickly try one more example. Let's try one where we break the total gross pay out by year, right? So you see that we have in here the pay period ID, right? So select star from payroll. And, you know, I might want to group by pay period, but that doesn't help me because the pay period ID if you look, that is not payroll, paychecks. That value is that's paycheck. Boy, I'm really there we go. Okay, see these values here are dates, and I just need the year part of that date out of there. So you might say, well, how can I easily extract the year from this? And there's a couple of techniques that you can do. I'll show you one here. I can say if I were to cast this as a varchar, right? And then if I take the left 4, that should give me what I want. Let me see if that works. I gotta say as here, Mike. That might work. Okay, so now I just have the year. If I keep going, I should see 2019's in here. I got to go a ways, but they're in there somewhere. So this gives me the payroll year. And then now I can get the sum of the gross pay. Let's do hours worked while we're at it. So why do I want to show you this example? Because when you run this, you get this, it needs to be in the group by clause. So again, group by doesn't know anything about payroll year. It knows this. So I actually have to group by this. And you might think this is incredibly inefficient, right? But this is just the way you have to write the query. We'll learn how to simplify this in a bit so that it doesn't look so ugly. And there you go. So these are each of the years. 2018, that's how many hours worked. That's how much we paid out in payroll. 2019, hours worked, what we paid out in payroll. 2020 so far, hours worked, what we paid out in payroll. That's basically it. If you want to break it down year month, don't go out to 4 places. Go out to give me the left 6, and now it's year month. And so I have, well, technically no. Yeah, it is. It is. It's just not sorting them the way I want. So I'd have to do an order by that. And now I can say payroll year. And now it should look a little better here. There you go. 2018 January, 2018 February, March, April, May, June, July. 2019 January, February, March. So now you have a breakout by year and month of that payroll. So that's aggregates. Very useful. Group by, extremely useful. Having, extremely useful. but this looks ugly. So in the next unit, we'll talk about how we can sort of simplify these queries so they don't look so bad. All right, so if you remember that example that I just showed you, and I showed you how in that group by clause you had to like do some really weird stuff, and it's like very counterintuitive. Let me show you how you can simplify your select statement by creating these temporary named queries with the with statement. So before we do that, let's talk about subselects. You probably didn't know this, but you can nest your select statements in any portion of an existing select statement. That is, you can have a select in the where clause, a select in the from clause, a select in the projection. So in essence, a select in the from clause would mean that you are making a table and then using that table as a way to nest it. And this is one way we can get around the weird naming that you are seeing in there. But when you nest, it brings its own level of confusion. So one way that the SQL standard got around this is by making named queries with. So basically what you're doing here is you're saying with, and then you're giving the query a name, and then you can optionally give it the columns, and then as the select statement, and then you can name another, and then down here after all the with commands in parentheses, you then run a select statement that uses your named queries. And this sort of breaks up the query logic a little bit so that it's a little easier to digest. The pill is a little easier to swallow. So again, let's try a demo. And what I'm going to do first is I'm going to take the query I just wrote and rewrite it with. And then we'll do this one with employees more than the average to show you sort of how that plays out with. All right, let's get back to it. All right, so here we are. I'm back, and here's this query that I wrote. And what kind of is annoying is the fact that you have this left cast paycheck pay period blah 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 in the group by, and it's also in the payroll year. So if you think about this if you think about this before you do the aggregation as its own table, then the query becomes a little simpler to write. So let me do this. Let me take this, move it down here. And let's just write the following query. Let's write a query that just does the following. Let's do select this as payroll year. And then let's also grab this total hours worked because I need that. And then let's also grab this gross pay. And I'm not doing any aggregations. And I'm going to grab this from paychecks. And I'm going to run that. I need to put the word from in there, Mike. That would help. And then this gives you nice output, right? Now you might say, boy, I'd love to write this query here using this table here. And you can do that. If you give this an alias, watch this. I can say select star from this. I'm going to do a lot of crazy indenting so that it really sort of stands out. As I'm going to call this P for paychecks, right? And then I'm going to say select P dot star. This will run and look exactly like it did before. So in the from clause, I'm treating this select statement like it's a table. So now I can do this. I could say select, and this is called payroll year. And then I could say the sum of paycheck total hours worked and the sum of gross pay from this, and then group by payroll year. And you might say, Mike, this doesn't look any easier than what you just did. Okay, this query is the same as the query below. And so now is the point where you say, that's great, Mike, but, oh, I ordered by payroll year here. I guess I should add that too. Now they're identical, okay? You might say, great, Mike, but I don't see how this up here is any better than that. And the answer to that is it really isn't, okay? It's not because we've, this part is simpler, but we had to complicate things with this subquery and from, right? So what does this have to do with? So with is a way to sort of simplify all this by avoiding this nesting and avoiding all this complexity. So basically how it works is you say with, and then let's call this payroll with years as, and then now my query is this. Okay, and I'll move this over. Okay, so that's my named query. So now here I can run a select with that query, and I can say select payroll year. I can actually say this, payroll year from payroll with years group by payroll year, order by payroll year. Okay, so this, you might say this doesn't look any easier either. Does the same thing. So all three of these do exactly the same thing. They all do the same thing. They all have the same output. My bet is the Microsoft SQL Server optimizes them to work the same way. The advantage of writing it this way is it allows you to think about the problem you're trying to solve and break it up into easier chunks, right? When your query writing becomes really complicated, sometimes it's easier to solve one problem first, then say, well, hell, if this was a table, I could easily figure out, knowing that this is a table, how I can turn that into the query that gives me a total number of hours worked and total gross pay by year. I could do that, right? That's simply this. Right, which is a very straightforward query. So that's the advantage of using with, is with allows you to make these temporary objects that only exist within the scope of your query, and then that in turn help you simplify the query writing that you write. So let's do one more example here. I'm back in the employees table at this point. And what I want to do is I want to get a count of employees by department, right? This is easy to do. And then let's do, right, and then from employees group by employee department. Okay, and we run that, and everything's fine and dandy. Now, you might want to get a report that says which departments have more employees than the average department of employees, right? So here's the average, right? If I do select average, well, see, that's not going to work, because what I need to do is, I need to figure out the average of these, right? So that's where it ends up being a little more challenging, because I can't average I counted the rows, right? And what I need to do is get the average of these. Right? So see, this is a great example of where you might want to use the with command, right? Because if this was a table, you can get the average. So let's do that. So with, let's call this department counts as this query here. Okay. Now I have this table called department counts, right? So now I can say select average employee count from department counts. I should probably call this department counts because it has more than one count in it, right? So I run that, and the average is 9. So the average, if I look at this again, the average department has 9 employees in it. All right, now that I know that, I can actually answer the query. I can say select star from department counts where employee count is bigger than the average count. This query is a little complicated, but it's easy to understand, right? Because I use the with statement. Now, I could write this without the with statement, but it's damn ugly. I'm telling you right now. It's much easier to understand by breaking it up like I did, right? I can write this query. That tells me exactly what the departments and the employee counts are. Now, if I treat this as a table, how do I go about solving the problem? Well, it's easy. I only want to show these counts where whatever the average is, the rows are bigger than that. Simple. Okay. So that's a very good use case for using with to break up your queries into named tables that are temporary that you can then use in a subsequent follow-up query to solve the problem at hand. Great example of using with. All right, let's move on to window functions then. So window functions are a function which takes a set of rows, a group of rows as input, and produces a single output for every row. So it's the input rows are called the window. The set of rows as input are defined by partitions over the data in the from clause. So whatever you get in the from clause, you join 20 tables together and you get some massive table. Then you can partition that table into windows. And then those windows you can apply a function to the data set within each of those windows, and what gets output is a value. So it's like an aggregate operator, but because it takes a set of data as input, but it's like a regular mapping operation. It is a regular mapping operation because the output is, the input is a set of values, including the current row, and the output is a value in the current row. So the order of input matters to the window function in some of the functions. Some of the functions require the data to be in a specific order, and you can sort the partitions with order by. And window functions act like a reducer aggregate function, but really it's operating as a map. So let's think about this. We have this students table, right? Let's review sort of mapping, reducing, and window functions. So classic map, you just filter on where it's a junior, and then you get a subset of rows, but these rows map back to individual rows. Okay, we saw reducing, right? Reducing is an aggregate operation where now we don't see the original GPA anymore. What we do is we see an average of that GPA by year. So freshman, and then 4.0, 2.0, 3.0, and then juniors, it averages all of those out. So these rows are not in this table anymore. They are a summary. So let's look at how this works with a window function. So a window function has, a very weird syntax to it, but it's really easy to understand. And what you're doing is this is the function called rank. And what rank says is take this data and partition it by year. So we're going to have one partition of junior and junior. Right? We're going to have one partition junior, 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 and another partition freshman, freshman. And then it says now order them by GPA. So we're going to order them junior, 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 and freshman, freshman. And now apply rank to that. So the first freshman has a 4.0. The second freshman has a 2.0. The first junior has a 3.81, the second has a 3.45, and the third has a 2.40. So this rank function, again, this is a map because this applies back to the individual row. I can still go back to this 4.0 freshman and it's Robin Banks. Okay, but it's a function that applies to a set of data, right? So it takes other rows into account. That's why they call it a window function, because it allows you to look over other rows and apply a function to the value in that single row or tuple. Very valuable function, and it saves us from having to write some really complicated subqueries to perform the same kind of task. So basically, the expression that you see for a window function appears in the projection line, and it looks like this. You say window function over, and then in over you can optionally, that's what the brackets mean, you can optionally include a partition. If you don't include a partition, it uses the entire output of the from line, or the entire table if it's that. And then you can also include an order by, which will arrange the data in the partition. And this is very useful for certain functions that need an ordering. And there's three kinds, or three classifications, or three categories of window functions. There are aggregate functions, which return a summary available a value. These are similar to the aggregate operators and aggregate functions that you saw with group by. The only difference is they apply to an entire row. And then there's value functions, which look up a value in the partition. And then there's ranking functions, which assign some kind of ordinal value or percentage, if you will, to the data in the partition. Normally, the aggregate functions do not need to be ordered. It doesn't make sense because they're always going to return a summary, like give me a count over the partition. The value and ranking functions definitely need an order by, because the order in which the data appears in the partition will matter and will determine how those functions behave. Let's begin with the simplest of window functions, the aggregate functions. And the aggregate functions look very similar to what we learned just earlier with the aggregate operators. The only difference is that these functions behave over a partition, yielding the same value. Okay, so let's do a really quick demo where we look at the pay rates of our sales associates, and we'll look at those pay rates over department and over the overall average. And we'll calculate some differences and then maybe use width if time permitting. But the important thing here is to see how the window function is different than the aggregate operators, because the window functions apply to the individual rows. That's where we want to be at this point. Okay, so I've prepped this demo by doing a select statement already. This is our employees who are sales associates and their pay rates. And what we would like to do is perform an analysis of these employees by their department. So let me add the employee department here. Just for grins. And now what I want to do is let's sort it . Let's sort it by employee department. And now let's perform our analysis. What I want to do is get the average pay rate per department. Now, normally I would have to use an aggregate function to do this, but now I'm going to use a window function because what I want to put right next to ginger beer, right over here, is what the average is across the clothing department. So I do it like this. I want to compute the average of the employee pay rate over a partition by the employee department. And let's call that as average pay rate by department. So this is the average of the clothing department, and these are the employees' pay rates. This is the average by the customer service department. These are the pay rates. Cool. You could not do this easily with just aggregates and some kind of crazy subquery. It would be hard to do this. This is the point of window functions. They take into account the entire from clause and then allow you to apply some kind of operation over the value in the from clause in a different way rather than row by row, which is the default. So let's get the overall average as well. So average employee rate over the entire data set as overall average. Let's be consistent as average pay rate overall. That's good. That's the overall pay rate. That's the average pay rate for the department. That's the employee's pay rate. So now I am able to do some kind of analysis over this. For example, I might want to calculate the difference between this person, Gamble Moore, and their averages. So I could do something like this. I can say employee, let's try to think about this. So employee pay rate minus the average over the department. So see how ugly it's getting already? This makes sense for width, right? As department delta. And I forgot a comma, as usual. So this person here, you're a liar, makes more than the average, so her delta is positive. This person here, Yolanda's Myland, makes less than the department average, so her delta is less. But you can see this is starting to get really ugly, right? So this is where width comes into play. I can break this up into a width. I can say width. Let's call this, let me take this out. And let's call this with payroll. Let's call this pay analysis. I'm bad with names. As this. And then let's write a select statement that uses pay analysis. Let me make this fit here. Now I can say select star from pay analysis, and I'm right back where I started. Oh, I can't have an order by. Yeah, can't have an order by with your width. Okay, there we go. There's my pay analysis, right? Now I can add a column here. I can say add a column. Let's add the column pay, let's department delta. And now it's simple. It's just employee pay rate minus average pay rate by department. These values are now available to me to use in the query. These names here in the alias. That's the advantage of using with, right? It simplifies things a bit. So this is average pay rate overall as overall delta. And I need a comma right there because I'm a putz. And there you go. So that gives you a really cool way to build an awesome pay analysis query using window functions. Again, these are what are called the aggregate window functions. Probably the easiest ones to figure out to start. Let's talk about the value window functions. Value windows functions retrieve a specific value from the set of values within the partition. Ordering within the partition is required. Using the order by statement is required in there. And that's because you're trying to pull like maybe the next or previous value or the first or last value. And it doesn't make sense to do that unless there's some implicit order. If you don't put order by in there, it defaults to using the primary key ordering, which is probably not what you want. So it's always best to include that. So let's roll through a really quick example using the payroll database again with paychecks, and we will show you employee paychecks. We'll show you the current paycheck, the last paycheck, and the last two paychecks for any given employee. Let's get into the demo. All right, here we are back in Azure Data Studio. I've already staged this query. I have, again, my paychecks for employees in a given pay period. This is the paycheck that employee 9 got. The names really don't matter for this example. And I've sort of limited the range to make it simpler on me. And what we're going to do is we're going to go and pull out this person's first paycheck within this pay period and show it right next to here. So this is how much they got paid on this date. But let's go see what they got paid on the date before that within this range, if there is one. So the way we do that is with a value window function. We're going to say, give me the first value of the gross pay over, and we want to partition by the paycheck employee ID, right? Because we don't want somebody else's paycheck to show up here. We want this employee's paycheck to show up here. This is going to get long, so I might want to actually break this up like that. And then we need to order that by the pay period so that we are guaranteed that the data appears. Because if I want for the first one, I want to make sure they're sorted in a way that the first one appears. And I'm going to call this as first paycheck. Okay. So the very first paycheck for this employee was $25.84.96, and you can see that that is true because that's what this employee got paid here, and then now they're getting paid different, but their very first paycheck says that. Now, if you show an hourly employee, this makes a little more sense. So maybe I want to put that in here. Let me do a where and paycheck employee payroll type. The hourly employees have a little more entropy to their paychecks. All right, so this employee 11, their first paycheck was $37.27, and their next one was $186, and you can see the very first paycheck shows for every row. So now I know what this employee's first paycheck was. Cool. All right. Let's have more fun here. Let's get their previous paycheck. So to get their previous paycheck, I need to use the lag function. The lag function asks for the previous value over, and it's going to be over the same window, by the way, right? I'm going to ask for this over this same window. And this is going to be called previous paycheck. Okay, so the very first paycheck this person got, the previous paycheck is null because they didn't have a paycheck, right? But if you look, this is their current paycheck. This is their first paycheck. That's their previous paycheck. Current paycheck, previous paycheck, right? First paycheck. Cool. So this is, with this kind of query, you could do an analysis that shows you the difference between the current paycheck and a previous paycheck. If you're looking at this in other ways, you might look at this with orders, and you might say, well, you can see that the orders are going down week to week in quantities because from one week to the next, you can compare the previous week to the current week and see if the orders are going up or down. You can get deltas on the orders. So let's add one more for grins. Let's add a 2 weeks ago paycheck. So I probably want to put this first paycheck at the end, but whatever. So this 2 weeks ago paycheck is going to be the same thing, but the lag takes an argument how many back you want to go. So I want to go back 2. So in this case, we get paid once a week, so this is 2 weeks ago, right? And I'm going to call this previous paycheck 2 ago. I don't know, horrible name, but you get the idea. Okay, so now 2 weeks ago, didn't get paid previously. This is the first paycheck. So if I go down here to 489, the first paycheck is this one. 2 weeks ago was this. Last week was that. If I go down to this row, right, now it makes total sense because very first paycheck 2 weeks ago. Last week. That is the power of window functions. All right, probably the most confusing of all the window functions are the ranking window functions. These functions will retrieve a position from the set of values. And that position, how it's displayed, depends on the ranking function itself. And in all cases, we're going to need order by because we want to make sure if you're going to ask for like a rank, you need to make sure they're sorted, right? So row number gives you a unique number over the partition. Rank returns a rank like first, second, third, fourth. Dense rank is just like rank, except there are guaranteed to be no gaps or repeats. So if there's 4 values tied for first, then it would be, with rank, it's 1, 1, 1, and then the next one is 5. In dense rank, it would be 1, 1, 1. They're all rank number 1, and then the next one gets a 2. So you have to choose how you want rank to behave, rank or dense rank. Then you have n-tile, which in essence divides the partition into equal values and assigns a value between 0 and 1 to each value. So, is it the I'm sorry, that's percent rank. That's how that works. But n-tile will take a value. Let's suppose a partition has 10, and you divide it into 4 bits. Then the first 2, or let's say it's 12, the first 3 would have a 1, the next 3 would have a 2, the third 3 would have a 3, and the fourth 3 would have a 4. And so that 12 divides evenly into 4. So it breaks it up into groups and assigns a group to each number. And they're evenly split. So percent rank and cum disc, these are just different ways that you can partition the values across a range from 0 to 1. And these are best sort of explained through an example. All right, let's try out the different ranking functions here. And this is going to be a really simple demo to just sort of demonstrate how each of the different ranking functions works. Okay, so here I am out in Azure Data Studio, and I'm going to just execute this statement and then just sort of explain what's going on here. So I am looking at the employee department, and then for each department, I am showing you the row number function, which, by the way, if I were to add employee ID in here, because the surrogate key starts at 1, these row numbers will match the surrogate key, but that is not necessarily always the case. That's just because our surrogate key starts at 1 and our row numbers start at 1. And then rank, what rank does is apply an ordinal position to these values, and it applies that ordinal position when you sort it. So I'm taking the department and then I'm sorting by employee ID. So this person's number 1 because their employee ID is the lowest, and then this person's number 5 in the rank because their employee ID is the highest. But this could be ranking by salary. I don't have to do an ID here. I can do the employee pay rate or anything like that. N-tile is a way to bucket, if you will. So I'm saying make 2 buckets over this partition. So if I sort these people by employee ID, there's 1, 2, 3, 4, 5 in clothing. I said break them up into 2 buckets. So the first 3 people are in bucket 1 and the other 2 people are in bucket 2. So I said 2 buckets here. If I go down to customer service, there's a lot of people in customer service, but there's a big bucket of ones and then a big bucket of 2s. I could break this up into like 3 buckets if I want. And then if I look at customer service, these people are in bucket 1, and then these people are in bucket 2, and then these people are in bucket 3. It's an even distribution over the partition with ordering. So %rank, what %rank does is it establishes a value between 0 and 1, and that's the same thing that QMDist does. It establishes a value between 0 and 1. And what it does is based on the position in the order by over the partition, it will assign a value. So, it starts at 0 with %rank. And then the next one is the 25% mark. And then this one's at the halfway mark. This one's at the 3/4 mark. And this is at the 1 mark. Now, if you want to just think about that compared to QMDist, QMDist says, hey, there's 5 employees in this department, so I'm going to evenly assign a value between 0 and 1 to each employee. What %rank does is it says there's 5 employees in the department. Let's subtract 1 and make that 4 employees in the department, and then let's evenly assign a value to each between 0 and 1, whereas this one assigns a value that says, if I take 1/5, that's 0.2, 2/5, that's 0.4, et cetera, et cetera, et cetera. So it's just a different way to sort of achieve the same goal, which is to assign a value that represents where it exists in the position of the partition sorted. Okay, remember, all of these ranking window functions require an order by to make sense because they apply a specific position in there. So here's another great example. In the electronics department, we have 11 employees. So in %rank, they end up being even because you start at 0 and end at 1. And in QMDist, it's really just 1/11, 2/11, 3/11, 4/11, all the way up to 11/11. So it's just a different way to partition that same data. So there's a ranking window functions. All right, let's talk about SQL views. This is going to be the last thing we're going to discuss today. Views are pretty simple. A view is a means to save an SQL query to the database under a name. So this is a piece of metadata. This is also called a database object, like a table is a database object or a constraint is. And it is a data definition language. So you'll say create view, name of view as, and then select. And I usually begin my views with a V to make things easy on me. And then I can use the drop view command to drop the views and information schema views to see the views. And let's do an example by making a view. And I have the perfect query to use for the view. I'm going to take the one where I use that with statement to simplify things, and I'm going to turn that into a view just to show you that you can even take the most complicated of SQL statements and make it into a view. And views are great when you finally sort of hit the nail on the head with a query and you want to be able to share that query with other people's by adding it to the catalog. Okay, let's get started. All right. First things first, if I look at the database objects over here, you'll see there's tables and there's also views. And I already have one view that I made just to kind of demonstrate it. But let's make a view out of this query. Remember, this query we wrote is pretty complicated, right? And it shows you the employees and their pay rates, and it gives an analysis of their pay rates based on the averages in the departments and the averages overall. So this is a really kind of nice thing that maybe you want to put into a view. So basically, here's how you do it. You use the create view, and I'm going to call this V pay rate analysis, and then as, and then after the as comes your code that writes the query. And you run this, and you don't see anything. You just see command completed successfully. And if you go look at views now, you will see there is now a view called pay rate analysis. See that? And I can now, let's get this out of the way. I can now treat it as if it were a table. Select V pay rate analysis. And it executes that query as if it were a table. Now I can't update this because obviously it is a summarization of data from an original table, but if it were somehow if I were somehow able to insert information into this table and it wouldn't violate any of the data integrity constraints, then it would be an updatable view. Generally, updatable views are based on individual tables and have no data aggregations in them. But it's pretty cool that I can have a name like this, and it sort of simplifies things out. And again, you would make views when you want to share the query with other people who use the database management system, because once it becomes an object, you can then secure it and make it accessible to others. So because the view is a object, it should be able to be found in information schema. So if I say select star from information schema views, I should see it in here somewhere. There it is. And interestingly enough, there's actually the view definition in here too. So you can look at the actual code that was used to make the view in here with this. But where having this information is useful is you can now make an up-down script out of it, right? So let's complete this as an up-down script. This is going to be the verify. And then this is going to be the up. And then this is going to be the down. And remember, we always want a soft down here. So it's going to be, if exists, select from information schema views, where table name is V pay rate analysis. Then just like we drop tables, now we're going to drop view V pay rate analysis. And now I have an up-down script for this view. This view, I probably need to batch this. Mike, go, and then go. It doesn't make sense to do this all in one batch. There we go. And there you have it, right? So drop it if it exists, create it, and then verify that it's there. Okay. And once you get the view the way you want, you probably don't have to run the script anyway, but as you're developing it and figuring it out, this is a great way to do it, because if you need to adjust this, you can, and then you can always recreate the view in the process. Again, the important thing to recognize here is that view is a form of metadata. It's a database object, if you will. It gets added to the database itself, and it really is a way to preserve the query itself under a name. So it's very similar to what you do with, except it's permanent. Okay, so it's a permanent. Now, you can treat the views like a table. You can join one view to another view, all sorts of stuff like that. But generally, again, they're used to save important queries into the catalog so that other people have access to those queries. Whew, that was a long unit, but we covered a lot. We talked about aggregate operators and functions and group by and how they allow us to summarize our row output. We looked at the with statement and how we can simplify complex queries, which involve multiple select statements and or subselects. We looked at the power and functionality of window functions, which allow us to apply a function over a set of data, yielding a single result per row. We also understand the difference between mapping operations and reducing operations. And we saw how the window function is technically a mapping operation that uses a set of data. And then we looked at views, and views are a great way to take really complex queries and save them into the database so that other users have access to those queries. They don't have to run the source of the query, they can just call it by name.